So, good morning, everybody. Myself, Acharya Vishwendra, and today I'm gonna discuss a worksheet on shear modulus. Let's start with things. First question is shear modulus. I represent it by eta. So, the first question is dimension of eta. It is m1 l minus 1 t minus 2. Next question is SI unit of eta. So, it is Newton per meter square. Next is CGS unit of eta. It is Ryan per centimeter square. Next is eta is equal to, so it is the shear stress by shear strain. So shear strain, if take the example of this, suppose there is a cube of side L, and on applying a shear force on the cube, its top face gets shifted by a distance x. So the shear strain is gonna be x by L, and x by L is 10 phi, and if phi is very small, 10 phi is equal to phi. So we have three expressions for eta. One is this f by a x by L. Another is if we replace x by L by 10 phi, and the last one is replace 10 phi by phi. So these are the possible expressions. Next is a question is being given in which a cube has a side 2 meter, and on applying shear stress, shear forces on the top surface, we need to find the shear stress, which is force by area. Force is 10 is to power 6, area is 2 square. So on solving this, we get 2.5 into 10 is to power 5 Newton per meter square. Next is shear strain. It is x by L. On solving this, we get as 10 is to power minus 3. Next is eta. So eta is the ratio of stress and strain, which is 2.5 into 10 is to power 8 Newton per meter square. Next is shear angle, which is 10 phi, which is 2 millimeter by 2 meter, which is 10 is to power minus 3 radian. Next is shear angle in degree. So 1 radian is equal to 57.3 degree. So on solving this, we get 0.0573 degree. Next is time period of oscillation. So we know that f is equal to minus eta a x by L. So it is minus k equivalent into x. On comparing this equation with that of spring, we can say that k equivalent is eta a by L. Area is L square by L, so it gives eta into L. So the time period is 2 pi root m by k equivalent, which is 2 pi root m by eta into L. Now mass can be written in terms of density and volume as dV. So this is 2 pi root dl cube by eta L, which gives 2 pi root dl square by eta. Next is a question on this. Fluid is rotated and we need to find force on N1. So obviously all the forces are in the plane of rotation. So the vertical force, which will be tangential, is applied on the end 1, and it will be like this. So it will be tangential to the plane. So the shear force is equal to the weight of this particular liquid, which is dl into g. Next is shear stress on end 1. So we know that stress is force by area. So on solving this, we get dlg. Next is shear strain on end 1. So this is shear stress by y, which is here it should be eta. So here it should be eta. So dlg by eta, that will be the shear strain on this end.